Hi, you're watching the linear versus nonlinear notes. In this video, we are going to talk about the similarities and mostly differences between linear functions and nonlinear functions. And we're going to get this by looking at the graphs, tables, and equations. So let's jump right in. We're going to observe the following functions below and decide if they're linear or nonlinear. Well, for me, I think looking at the graph is the easiest way to determine if something is linear versus not linear. If you look at the first example, it's a straight line, so that's definitely linear. Second example, that makes a U. That's nonlinear. That's actually a quadratic equation, if you remember from Unit 1. The third example, you may think it's linear because there are two straight lines, but together this forms a V, and that is not a straight line across the whole graph, so this is nonlinear. That's an absolute value function. If you look at the equations, you're going to notice that it has to do with the x value. So if you look at the x value and it's just a plain old x, you're looking at something linear. If it has something fancy like an x squared or absolute value bars with the x, that's problematic and it is not going to be linear. So just be on the lookout for oddities with your x. The last thing that we can decide or determine whether or not something is linear versus nonlinear is by looking at its table. And we want to look at patterns. So the first thing that I'm noticing in my linear graph is that the x values are going up by 2s every single time, and the y values are going up by 1. This is a constant rate of change. Change in y over change in x is our slope. So this has a slope of 1/2. It has a constant rate of change. Some might get really excited, like I'm so excited right now, -4 to -3 to that's adding 1 every single time. But then my hopes and dreams are smashed when I see that I go down by 5, then I go down by 3, then I go down by 1, then I go up by 1. This is definitely not linear. It doesn't have a constant rate of change. No slope can be found. The absolute value, again, you might notice that with the x's that they typically go up in a steady rate when you look at a consistent pattern. It's the y's that can sometimes throw us off. Check this out. We're going down by 1, down by 1. You might get excited until you see it goes up by 1 and then up by 1. So not constant rate of change. All right, we're going to summarize some things in the table. As you can see, I've typed some things in for you. This is just summarizing everything that we just talked about up above. So with the graph, you're going to write straight line for linear. Nonlinear, not a straight line. When there is an equation, we're just going to look, at the plain old x. It should just have plain old x. And nonlinear is going to have fancy things like x squared, absolute value bars, maybe x cubed. What am I missing? Maybe like the square root of x, maybe an x and an exponent. Some crazy things will be happening. Okay, so that's everything that we talked about with graphs and equations. And with tables, what we just talked about, linear equations have constant rate of change. That's a slope. And then nonlinear does not have a constant rate of change. Okay, so make sure you fill in this table. Even though I didn't handwrite it in, the stuff in purple and pink is what you want to write down. All right, example down below. Let's finish it up. Is this table linear or nonlinear? It's asking us. All right, let's figure it out. Is it linear? The x's appear to be going up by 2s every single time. So that's good news for us. What's happening with the y's? Ooh, looks to me, yes, they're going down by 3. So if we want to calculate the slope, just because we're fancy, change in y divided by change in x, blast from the past. Okay, so is this linear or nonlinear? Let's answer the question now. Well, it's linear because why? It has a constant rate of change or slope. It has a constant rate of change. All right, now here's where we need to probably brush off some cobwebs. Full on disclaimer, we're going to write this equation right now, but please know that later in the unit, we're going to do this more and more and more and more. So this is great. All right, so when I look at that, oh, why is my screen jumping? It doesn't want me to write the equation. Okay, so when I write an equation of a line, I like to write it in y equals mx or y equals b plus mx. So mx plus b, b plus mx. So y is going to equal my y-intercept, so my starting point, which is 2, plus or minus the slope times my x value. In this case, my slope is negative 3 halves x. And there, my friends, is our equation. But like I said, if you didn't follow along with that, we are going to dive way deeper into how I just did that later in this unit.